Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the smart manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the smart manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee by efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over sure.
Hello, ladies and gentlemen. If you can hear my voice, please in the chat box say hi to me. Let me know uh, if our system runs well so we can begin. Let's wait for a few seconds. Or if you cannot hear me, please also say no to me. Wonderful. Thank you. I will just not then every one of you since I'm still checking the checking my system. All right. I guess that's everyone. Yes, all right. Thank you for everyone who replying my request. Let's begin, shall we? Yes. Oh, by the way, do you like the video I shared in the very beginning? That's from our sponsor for this event today, our business partner. I will introduce the business partner later to all of you, so you can looking forward to it. But now let's officially begin. Hello, everyone. We are happy to welcome all of you to our webinar today entitled the 2023 ASEAN Additive Manufacturing Summit Medical Device Innovation Technology. Brought to you by Ringer Events. I'm Jack, your host for today's event. In today's webinar, we will hear from industry experts on the trends and developments in additive manufacturing and how this is being applied in various industries in the medical fields. As we all know that Asia is a major player in this industry and the region has been a key market for innovative additive manufacturing technologies and materials. So today, we will hear from the experts where additive manufacturing can be fully maximized and how this can be done efficiently. We will also be able to listen to industry experts on improving production while taking note of the market trends too. Opportunity as well and challenges in today's medical sector. So let's begin. Um, Let's have a look at our agenda for today. For our agenda today, we will firstly have three presentations by our expert speakers, followed by Mr. Joey Roy Bonak, Associate Director, Colliers. Okay, because I cannot, hear your applause, so please give a big hands to the speaker. Second, Dr. Archali Manonukul, Principal Researcher, National Metal and Materials Technology Center, NTEC, NSTDA, Thailand. Sawadika. Thirdly, let's welcome Dr. Renter Y. Cafino, MD, DPBO, HNS, Medical Officer, IV, Zamboanga City Medical Center. All right, so delegates, if you have any questions, please feel free to type in the chat box right now or later during their presentations. The speakers will answer them in the Q&A session after each sessions. So let's begin. Before we start, I would like to acknowledge and thank our business partner, HBD. HBD also has its own booth at this event where you can chat with its representatives and learn more about its technology and products portfolio too. Later, I will explain how you visit the booth. Actually, it's very quite easy. I mean, it's just on the left hand side, right? You can see on the menu bar the ebooks function. But if you go to the ebooks right now, you will lose the chance to listen to me and also the presentations. So later, we will have a break time. During the break time, I will teach you how to go to the booth later. And also, not only that, you can go to their booth, learn their information, and maybe there's some materials for you, and also you can watch their videos. Okay, so let's begin with our presentations. Let's welcome our first speaker today. Our first speaker today is a seasoned expert in this field, Mr. Joy Roy Bolnock, Associate Director at Colliers. He will kick off our summit with an insightful overview of the additive manufacturing industry in Asia. So now let's all welcome Mr. Joy Roy Bolnock to start his speech. Okay, Mr. Joy, you have the floor now. And delegates, don't forget, you can ask your question whenever you want in the chat box to the speaker.
Okay, so for today, I'll be presenting Asian industrial market updates and what is really driving the manufacturing sector, especially the additive subsector. We know that the Philippine economy, major economies in Asia, you have China, South Korea, India, Indonesia, Thailand. These countries are expanding at a very rapid pace. And as a result, we are seeing the manufacturing sector also growing, especially the additive sector. But moving forward, what do we expect? I think what's important to highlight here is what are the prospects that we are seeing for this additive sector, for the manufacturing segment. And will it be influenced by growing population, by expanding economies, improving infrastructure? So definitely a lot of factors to be considered. But let me first highlight on what we see for the ASEAN economy. So as you can see here, major Asian, ASEAN, Southeast Asian economies: Philippines, Singapore, Malaysia, Thailand, Vietnam, and Indonesia. And what's notable here is that these ASEAN countries continue to record a very fast pace of economic expansion. So, leading the way, of course, is Singapore, followed by Vietnam, but the Philippines also catching up. We did not include here China, South Korea, India, mainly because these already are major Asian economies. So we just wanted here to look at which emerging economies in the region have substantial, tremendous potential for further growth. So, as you know, the growth was disrupted in 2020 and 2021 because of the COVID-19 pandemic, but these economies are starting to recover. But we also need to consider, for example, if we are to observe manufacturing sector and growth, what will further contribute to this increase in consumption and demand? We believe that this will partly be influenced by growing GDP per capita. So, for those who do not have a background in economics, when you explain GDP per capita, so you have the entire economy of the country divided by total population. So that's how the GDP per capita is derived. But definitely, if you talk about GDP per capita, you have the likes of Singapore, Malaysia, really having tremendous potential in terms of growth. That's why it's no longer surprising to see these economies recording expansive growth in terms of purchasing power, in terms of their ability to acquire basic commodities. And that has been resulting also in greater demand for manufactured goods. Now, we just want to highlight here manufacturing as percentage of GDP in major Southeast Asian economies. So, looking at the Southeast Asian countries, a very good example is Thailand, and about a quarter of its GDP captured by manufacturing. And then you have the likes of Malaysia, Singapore, Vietnam. But what's not included here is China. But of course, China has been a major global power in terms of manufacturing. You have a lot of factories in China, in South Korea during the boom years of 80s, 90s. A lot of companies put up manufacturing operations in South Korea. India also is a major regional economic powerhouse when it comes to manufacturing. But if you step outside of these three major economies, so you have the likes of China, South Korea, and then India, definitely these are major countries that we need to watch out for in terms of manufacturing output. And I believe that a lot of people will no longer be surprised to see the likes of Thailand and Malaysia, Singapore cornering a lot of investments, manufacturing investments. And we attribute that because of we attribute that to the improving infrastructure, skilled manpower, lower cost of electricity. So there's a lot of economic reasons and economic factors why these countries continue to be major hubs for industrial operations for manufacturing. As I mentioned earlier, infrastructure is very important because if you want to attract a lot of manufacturing companies, you need to make sure that you have quality transportation network, roads, cargo railways, passenger railways, subways, trains, because that also empowers the manpower, the labor pool. How easy will it be for the employees to commute from their places of residence to, for instance, the places of work, to the manufacturing site, to the factories, right? Um, Overall, we have been seeing a very good infrastructure spending. And I just want to highlight here the Philippines, because the Philippines is a growing economy in Southeast Asia, one of the fastest growing economies in 2022, and one of the most dynamic for 2023, especially now that it's recovering post COVID. Its infrastructure allotment. So the part of the GDP, of its GDP or economic output, that is allocated on infrastructure currently hovers between 5 to 6%. So previous is only 3 to 4%. Now, why is this ideal? Because if you look at these economies here, China, India, Vietnam, Thailand, Indonesia, they have been allocating what, 5, 6, 8, even 9.5% of their country's GDP on infrastructure. And one major reason why these countries are doing very well in terms of competitiveness. Look at the infrastructure ranking out of 141 countries. These economies are part of top 50%, top 40, 30% of all economies surveyed. And one of the major reasons why these economies are faring very well in global surveys is because of substantial infrastructure allotment set aside by their respective governments. So, if I am an investor, a manufacturing investor, a manufacturer, and I want to put up a site, a factory in Asia, definitely top of my list will be the likes of China, Vietnam, India, Malaysia, because they are doing very well in terms of competitiveness ranking, and also as in terms of infrastructure competitiveness. So it's no longer surprising to see China, Vietnam really attracting a lot of manufacturing investments. And one indicator also that we need to consider is corruption. So it is noteworthy, especially for economies that are doing very well in terms of anti-corruption initiatives. For example, if you look at Singapore, it's ranked fifth. Malaysia ranked 61st out of more than 100 countries, economies surveyed. And the Philippines is improving on its ranking. But what's notable also is to see Singapore doing very well. So one of the cleanest governments in the world, definitely, and again a contributing factor. One of the major reasons why Singapore attracts a lot of manufacturing investments and ease of doing business also. I want to highlight that if you are a country that wants to corner a lot of investments, whether it's manufacturing or transportation or logistics, it is crucial that you streamline your business registration system. And as I highlighted in my previous presentations for Rainier, it's important that you do very well in terms of ease of doing business. This is a World Bank survey, so they would track the um, business registration system of every country. Has it improved? Was it easier to put up a business, to open a business? How many signatures are required? So again, if you recall my previous slides, Singapore doing very well, Malaysia, Thailand in terms of attracting a lot of investments, in terms of enticing businessmen to put up operations, and that is because their countries are ranked fairly up there in terms of competitiveness, business competitiveness. It's very easy for these countries to open operations, open a manufacturing plant. So I believe that this is one key consideration for a lot of companies that are looking at establishing manufacturing operations, not just in Asia, but also globally. But again, one factor that we need to highlight also, uh, in terms of market size and why countries decide to open operations in these economies, is the population. So estimate as of 2022, so Thailand 71 million, Malaysia 33 million, Singapore 5.6 million, Philippines 116 million, Vietnam 98.2 million, Indonesia more than 275 million residents. But what is the forecast? Of course, again, this is very important. This is crucial because if you want to put up operations in a certain country, you need to make sure that you have a consumer base, and you have to ensure that this consumer base can afford your products. They have purchasing power. So if you recall my previous slides, they're now slowly, gradually being tied into each other. So I started with infrastructure, with GDP, with GDP per capita. But the question is, will the population be able to afford the products, the manufactured items? And again, if you talk about the market, how will your market expand? So again, this is how these economies will expand in terms of population in about 7 years. So again, by 2022, that's the population estimate. Thailand from 71 million, it will grow to 72. Malaysia 36.7 to from 33.9. Singapore from 5.6 to 5.9 million. Vietnam 103 million, from 98.2, Philippines 105.6 million to 130 million, then Indonesia 292 million from about 275 million. So as you can see, these economies do not just have improving infrastructure, they don't just have improving business registration system and expanding economies, but also have growing population. And again, this is important if you are to consider um, which country to invest in. Will you have a very big population as consumer base, and will it have the purchasing power when acquiring your manufactured items? So foreign direct investments, when we talk about FDI, so it's a mix of manufactured items, it's a mix of logistics, transportation, and storage, and other investments. As you can see, China is a major economy when it comes to attracting investments. 190 billion, that's as of 2022, followed by India, 52 billion, or followed by Malaysia, 60 billion, and then India, 52 billion, then Indonesia, South Korea, Thailand, and then the Philippines at 9.2 billion. But again, outside of major Asian economies such as China, India, and South Korea, it is really Indonesia and Malaysia that are attracting a lot of investments. And these are two countries that are cornering these manufacturing projects, mainly because of factors that I highlighted earlier. You have improving infrastructure and easing business registration processes. Now, manufacturing index is important. A score higher than 50 indicates expansion of manufacturing activities, and the Philippines so far doing well, more than 50 post-pandemic. So 2021, 2022, 2023, definitely higher than 50 score. So that indicates expansion of manufacturing activities. But across Southeast Asia, you have Indonesia and the Philippines that have continuously rising purchasing managers index, more than 50. Malaysia, Myanmar, Thailand, and Vietnam, well, slightly lower than 50, but that lower, relatively lower score is mainly because these economies already have strong manufacturing base, unlike the Philippines, which only attracts what in 2022 9.2 billion in foreign direct investments. You have Malaysia and Thailand attracting more than 10, 20, even $30 billion in foreign direct investment. So this is probably a base effect. Now we talk about advanced manufacturing in Asia Pacific, and what we have been seeing is that technology development is definitely reshaping the manufacturing scene, especially in Asia Pacific. The share of Asia Pacific region to worldwide manufacturing output is almost 50%. Specifically, that's 48.5%. So just imagine APAC really cornering a lot of manufacturing and investments. And this is a region where we really see a lot of manufacturing projects, a lot of manufacturing investments. Why? Because, well, number one, labor is relatively cheaper in this part of the world. You also have electricity costs somehow. Um, Supported by the government. You have lower electricity cost in some parts of Southeast Asia, even subsidized. But I want to highlight here three key areas that are driving technology development in Asia Pacific, and these are advanced materials, net zero carbon emissions, and additive manufacturing, which is really driving technology development in terms of manufacturing in Asia Pacific. So a lot of technologies now being infused into additive manufacturing, and we only see further growth of this additive manufacturing subsegment moving forward. And again, if you recall my previous slides, these are all now contributing to this greater demand for advanced materials manufacturing and even additive manufacturing, the population, GDP expansion, rising purchasing income, purchasing power. All of these are now chipping into a greater demand, additional demand for additive manufacturing, especially in Asia Pacific, which corners or holds about 50%, almost 50% of manufacturing output globally. And again, in Asia Pacific, we have been seeing a strong and rapid proliferation of additive manufacturing technology and 3D printing in Asia Pacific. You have these Asia Pacific, Asian economies that are leading the way and leading the region in terms of additive manufacturing technology. Talking about China, of course, with its huge population, very good infrastructure, GDP expansion, very good network quality, and also improving business climate because of the support of the government. South Korea also, given its continuously rising GDP per capita, and purchasing power of South Koreans. Singapore, again, because of its honest, clean government, but also mainly because of fostering a very attractive manufacturing technology site for a lot of operators. And again, Japan, again, because of its population, its rising population with the growing disposable income purchasing power, and also mainly because it helps foster a very attractive and a very streamlined business registration system. We have to note also that China is ranked as the third largest additive manufacturing market globally. And the share of Singapore to industrial 3D printer installations in ASEAN or Southeast Asia is one third or 33%. So if you just look at these two economies, definitely these are two countries leading the way in terms of additive manufacturing, 3D printer installations, talking about China and Singapore. But again, the other economies with a growing contribution in terms of 3D printing and additive manufacturing technology are South Korea and Japan. So overall, we have been seeing advanced manufacturing in Asia Pacific. And this is how Asia Pacific economies have accelerated the adoption of advanced materials. Investment in research and development, this is crucial. This has to be at least 5% of your country's GDP. Other countries are only allocating 1-2%. The Philippines is one example of this paltry investment on research and development. And one of the major reasons why, if you look at the Philippines, it's not really a country that is on the radar of additive manufacturers at this point. But hopefully, this changes in the future. Collaboration with other stakeholders of public, private sectors, the private companies, and the government officials, customizing material properties for various industries, looking at further growth expansion of additive manufacturing in Asia Pacific, and reducing materials cost for additive manufacturing. Again, one key highlight, an important factor to reduce material cost is to improve infrastructure network, because it's now easier to travel from the factory to reaching your main market for your finished manufactured goods. So again, these four factors are important: R&D investment, collaboration with between the government and the private players, customized material properties for various sectors, for various players, and again, reduction in the materials cost for additive manufacturing. So what will accelerate additive manufacturing in Asia? We've been seeing advanced manufacturing in the region, but I want to summarize my key points earlier. Again, population growth, that is important, but it's not just enough that you have a population that is growing. You have to make sure that even if your population is growing by about 1, 2, 3% every year, do they have disposable income? Do they have enough purchasing power? And again, what will fuel the region in terms of demand for advanced manufacturing, 3D printing, additive manufacturing? It's regional economic expansion. And definitely, there's no a shortage of economic expansion. Talking about Asia Pacific, Southeast Asia, Asia is definitely a hub for advanced manufacturing. As I mentioned, this is a region that corners almost half of total manufacturing operations in the world. But again, what's important is we make sure that we have people, consumers that also have growing purchasing power, and that will only happen if they have continuously rising and expanding GDP per capita. So GDP on a per person per citizen basis. And overall, it's really the economic expansion that will further drive the growth of advanced manufacturing in Asia. All these infrastructure, all these business registration systems, anti-corruption efforts will not really bear fruit unless we see further expansion of these economies, especially China, South Korea, India, and even the emerging manufacturing hubs and consumer markets in Southeast Asia, talking about Indonesia, Thailand, Singapore, and Vietnam. So that concludes my presentation. Again, thank you for listening. So, really interesting um, reports we've seen, even the previous reports on additive manufacturing, 3D printing. And I hope you also check out Collier's social media pages. We have a LinkedIn, Facebook, Instagram, Twitter, and the YouTube page where you can learn more about the property market and other allied sectors and what do we expect moving forward. So thank you again for listening. I hope you learned a thing or two. And good day to all of you and enjoy the rest of the day.
From Mr. Joy. Joy, now I would like to invite you to join our live Q&A part. So delegates, if you're ready, you can prepare your questions to ask Joy. Thank you. Okay. So, dear delegates, I'm receiving a very unfortunate news I would like to share is that Mr. Joy Roy Bonak will not be able to join the live Q&A. However, I will be sharing his contact information in the chat box. Now, if you have any questions or you would like to have further discussions about his topic today, which is very interesting, I think that's very insightful, so very meaningful as well. So yes, I'll just share his contact information in the chat box. And also, remember, in the very end of his presentation, he also showed social media channels that the Joy Roy Bonak reminds you to follow, right? So, yes, don't forget to follow and to search to like their channels. Okay, so let's wait no more. Let's welcome the next speaker. All right, joining us next is Dr. Anjali Manonuko. I hope I pronounced your name right. A distinguished principal researcher at the National Metal and Materials Technology Center, MTEC, NSTDA, Thailand, with a focus on materials extrusion additive manufacturing for metals. She will enlighten us on the low-cost alternative options in this dynamic field. So, Doctor, you may have the floor. I'll see you later. So, delegates, also we will have live Q&A later after her speech.
Okay, good afternoon, everyone. Yeah, thank you very much for the organizer to invite me to talk today at the ASEAN Additive Manufacturing Summit. Okay, my name is Anjali Mano Nukun. I'm from the National Metal and Materials Technology Center, NASDA, Thailand. So we want to share some of the work we done so far about additive manufacturing. So the topic is development of material extrusion additive manufacturing, or we call it MEX, for metals as a low-cost alternative. Okay, so this is the outline of my presentation. Okay, I guess I don't have to introduce the additive manufacturing, but we want to show the difference between the most popular one, the SLM technique, with other technique as well. Okay, then I'm going to do the introduction to why we're doing this technique comparing to with the other thing we do in our lab and other people. Okay, our lab actually metal injection molding laboratory, okay, which is very close to MEX. Then we're going to compare MIM and MEX, and then we show some of our work about the effect of the orientation on the MEX properties. Okay, so let's start the introduction. Okay, so for metal additive manufacturing, we have different process, as you can see on the slide. This is classified according to ASTM. The most traditional one is the powder-based fusion. The powder-based fusion, you can see that this is the logos are the companies that commercially available in the market. So there are many producers for the SLM, the powder-based fusion, either SLM or electron beam. Okay, there are also other techniques that you can get direct metal part. Now, what we interested in when they use either laser or electron beam, it's very expensive, and the environment that we have to operate in is quite hostile. So we interested in the indirect metal parts additive manufacturing. For example, the material extrusion and binder jetting. These processes are the process that you have the metal powder and then you have the polymer binder as well. Then when you form it by printing, you have to remove the binder and then do sintering. So that is why we call indirect metal additive manufacturing. You have to go through the process of debinding and sintering. Okay, but when there is no laser or electron beam, it's become much cheaper, and most of the things are the modification from the current process available in the market. Okay, so we're going to move on to the low cost metal AM. Okay, this is the overall picture of what we're doing in MTech in Thailand. Our vision is we want to have low cost metal AM available for Thai public and anyone else in the world as well, or in ASEAN country. So imagine that most people got the polymer FDM machine, the filament machine. Why do we have to go for the laser machine, which is like 20-30 times more expensive than the filament machine? So our aim is, can we use the polymer filament machine to do the printing, and then from that we take it to debinding and sintering in the powder metallurgy industry. So the whole point is we want to use equipment readily available in the industry: polymer processing, filament making for the polymer industry, and we want to use the powder metallurgy, the MIM equipment for debinding and sintering, and everything have to go to this readily available market. So to do all this, then we divided in different segments and working with different people in Thailand and around the world. So we have the first group is the filament making. The filament making is we use all the polymer equipment, and we work with professor in Leoben University in Austria and Yamagata University in Japan, that we want to produce the metal filament that are feasible and we can feed into the FDM machine, polymer FDM machine. With our experience with the MIM, then this one we can do it. Originally we think we can do it really easily, but actually there are more to that. So that is why we had to work with professor in abroad to do this. So this is one of our ongoing projects, and we also work with the current available machine in the market as well. They are closed system machine like Markforged or Desktop Metal that they are selling in um, actually at a quite when they come to Thailand, they will, or I guess it's the same to all the ASEAN countries. It's become very expensive comparing to the Desktop Metal or Markforged in the US or in Japan. So for some reason they become very expensive. So if we can use available FDM machine to do it, then it's cheaper. Okay. Oh, I forgot to tell you that the filament there are a few filament readily available in the market, but they use special debinding process. So that also one of the drawbacks. So we want to use normal debinding process as well. In our lab, we also do surface modification. The surface modification is because all the powder metallurgy or the sintering, they will have some porosity remaining in it. So the shot peening, the fine shot peening process that will close up some of the pores and increase the fatigue resistance. So I will show you some of these as well because we are doing them now. We also try to reduce the experiment by doing the modeling of all the process, the printing, the binding, and the sintering, and the mechanical properties after we already print it. We work with professor in Queen's Mary University of London and a few university in Thailand as well. Okay, and we also do some of have a project that build our own equipment so we can control the processing more instead of using the readily available, but they will be cheaper because you can build them up. Okay, so this is all ongoing, and our aim is to be able to produce medical parts using this cheaper technique. Okay, so at the moment we're starting with stainless steel filament, but it will go to the titanium 6-4 filament in a very short time. So this is example of the ongoing process that currently running, the one we're working with professor from Leoben University. Okay, the Leoben University, they are polymer people, they expert in polymer in the filament test in the fabrication of the filament. And we also have industrial partner in Thailand. These two companies, they are company that interested in the metal filament making, the selling the metal filament. So they support our research. And our lab is actually metal injection molding lab, and we have our younger researcher in polymer processing lab to come to help us with the filament part as well. Okay, and this is what we do. We produce a filament, control the test, the printing, and then study with the debind and sintering. Okay, this is the progress so far. The project has been ongoing for 6 months. So this is the picture of the filament making process. We can do our own filament. The filament have metal and polymer in it. We can spool them. We can put them in the normal FDM machine, and we debind sinter. And this is example of the part. Okay, we can control the shape as well. This is before sintering, and this is after sintering. They will change a lot. Okay, more picture of it. Before sintering is bigger, and then after sintering. Okay, and we can control the shape. Some of them we need support, but most of them we try not to use support similar to MIM. Okay. Then why we doing this? In our lab, we actually the metal injection molding lab in MTech is set up in 2004. We actually get funded 1 million euro, 1 million euros funded from the Japanese government, NADO, Japan. So all this equipment came in 2004. The process is we have metal powder mixed with polymer binder using the mixer, and then we got the granulated feedstock. We injected it into the metal mold, have what we call the green part, then solvent debinding. After that, we thermal debinding, sinter, and finish the part. Imagine that from this process, instead of doing the injection molding, we doing the printing. In order to do the printing, we have to do the filament making at that point. So we have 20 years accumulated experience on metal injection molding. That is why we shipping to mod to do the mix process. We have been doing the mix process for the past 5 years. Okay, this example, what we do in our lab, when we have the equipment from Japan in 2004, um, we then after that we accumulate a few experience and then we start doing industrial based project. So this one is actually is a custom Thailand is a company in Thailand that do metal injection molding MIM. And at that time in 2005, they cannot produce commercial commercially pure titanium and titanium 64 using MIM process. They have hired the Japanese professor to do some research for them for titanium sintering MIM, titanium MIM, but they can't commercialize it, produce them commercially. So they asked us to do it again. We do it in Thailand with the company, with custom, and the process is we do all the optimization in our lab as a lab scale. Then we transfer the technology to custom Thailand for commercial production. Um, what is the most interesting part one in this project is when we do it in our lab, we can do them really nicely. After all the optimization, the scientific optimization, we can do it really nicely. You see the dashes line in this slide. That one is the variation that we get in our lab. The most important one is the elongation. Okay, the elongation is the horizontal axis, the x-axis. The standard Japanese is more than 10% for titanium. And what we can do in our lab is 18% average. So at that time in 2004 and 5, we actually can do it much better than anyone else in Japan as well. So the interesting one is after that we transfer to custom Thailand to the company, and this is the first batch that we did at the company, and elongation dropped to 4%, and it is the most common issue happening when we move from the lab to mass production. Things will happen. Something will went wrong. So so this one, we have to go through the process that operating in the company because we thought we told them everything and they do it according to what we suggest them, but eventually we found out what the issue is. So the issue is the contamination. So we suggest the company what to do to minimize the contamination, what they want to do. After that, then they can, the solid line on the bottom graph, this one, what they can do in the company. So the company can actually produce in the range that we can produce in the lab. At this project, then the custom become the second MIM company in Asia that capable of doing titanium and titanium 64 metal injection molding in 2005. So this is one of the early project we did in our lab. Then we also have this another example of the project that we're really proud of is to produce titanium foam. Okay, this one we work with another MIM company called Taisei Cochlear Thailand. So they want titanium part that really porous, have many high porosity. We actually go through the process with them similarly. We optimize everything in our lab. This one we have the pilot scale in the company, and now the company is mass producing them as well. Okay, and we still continue working with Taisei Cochlear until for the past 10 years. So they're one of our main sponsor in the lab. They have different things they want to improve on their MIM materials, but mainly they recognize our expertise on titanium. So most of the work we done with Taisei Cochlear is on titanium based alloy. Okay, now come back to the 3D printing. So we have the experience with MIM, especially titanium MIM. Now the interest of the industrial want to utilize the 3D printing, so we want to combine them. Okay, so as I told you that the beginning is the same. We have metal powder and binder. If it MIM, then we granulate them and put injection molding machine. For the 3D printing, we have to make them in filament, or some company like Desktop Metal, they make them in bar feedstock and then put them in the 3D printing machine, got the part, go to the debinding and the sintering process. Okay. In the market, there are 3 different type of mix machine. So you can either have like the screw-based one or the puncture one or the filament one. So bottom is the company name. You see commercialized company. So this three, the top one are the machines. So you see that the most common one at the moment is the filament one. 80% of the work done in the market done at the moment in research development are on the filament one. So that's why we focus on the filament base. The commercial machine is close commercial machine is Markforged, which they can do it really nicely. We also operate on the machine as well. And they also, BASF also have the filament, commercial filament, as I told you. But the commercial filament in BASF, they have to use catalytic dividing furnace, which is another non-common furnace in Thailand. In Thailand, we don't have any catalytic dividing furnace, but it's quite common in Europe. So BASF actually sell quite nicely in Europe, but not in Asia. Okay. This is we borrow it from Markforged. Actually, we actually work with Markforged in Thailand, trying to introduce people to Markforged as well. So this is a Markforged machine. They have two rollers. One filament is metal and one filament is ceramics as a separator. So this is another thing that they can different from SLM machine. That this one the separator was there so that we can remove the support from the metal part that we want using hand without like equipment, which is different for SLM machine. Okay. And they do the printing, they do the solvent debinding, and this is the sintering, and then we got the part. Okay, some polishing, and then we got the part. Comparing MIM and MEX, okay, you see the MIM, the surface finish, this is as sinter, okay, after we get it out of the furnace. The MIM, the surface finish is so nice because they're really smooth, just from the picture, because we place everything into the metal mold. Okay, but for MEX, because we do layer printing for the 3D printing, you can see the layer really clearly. This there, if we print slower, then the layer, the surface finish is much better, but they're still there. The staircase effect still there because they are 3D printing. Okay. Other thing is when we use metal mold in MIM, then it's become really well. We have to do mass production for it because the mold is expensive. The mold is about like 300,000 baht in Thailand for normal mold in Thailand. So we have to produce a lot of number of parts for this. The 3D printing will, as we know, will have freedom of the shape. Then we don't have to do. We can do like small production for it. Okay. This is comparing the mechanical property. Everyone always asks about it for 17.4 pH stainless steel. Okay. If you rod metal, then you got yeah, as you see, MIM and MEX are relatively good, and they are actually according to the international standard for MIM, so they are quite comparable. Okay, so our aim is we want to be able to make the filament that put in any FDM machine and produce similar thing as well. Okay, so showing you some of the results that we have done so far. These things are for actually for the Markforged machine. So we're working with people who have Markforged machine in Thailand. Okay, so the filament itself shows that the powder are packed very nicely. Okay, and what we do is we do things common to everyone. That's starting to do 3D printing, study the orientation of the properties of the part that produce after using the technique, the MEX technique. Okay, so we print the tensile test bar and the 3-point bending sample in 3 different orientation. We call it the flat, the side, and the vertical. And that is the printing direction. And we want to see how the property different in all direction. Okay, and most people haven't done it very details like this. So we at that time we were one of the people that do it in very details way. Okay, so the picture showing the first, these are the green part. mean the part that we get it from sintering. So the parts look a little bit um, gray. They have polymer and metal binder in it. Okay, after debind and sintering, then they shrink a lot. You can see that they shrink a lot. This is the flat, the side, and the vertical. The vertical, the printing, the layer is perpendicular to the loading direction. You see, okay. And this one showing you the support as well. You see that this is the side part. Then the gate length will be cantilever. So we have to have the support. And the white that you can see are the ceramic layer separator. So when we finish the sintering, we can literally remove them, okay, because the ceramic will prevent the metal to join together. One thing that come with the mix printing is you will always have this triangle shape, especially on the peripheral. Peripheral, when you do FDM, we will have about 1 to 3 layer of peripheral that we print before we do the infill in the middle. Okay, because the peripheral is all in the same direction on top of each other, we always have this little triangle. When it's flat, then it's pointing up like this. Then the side and the vertical, the it will look like this. Okay, so it will be there. We try to optimize everything, but we can't eliminate it. So need to a group of people in the world actually trying to develop the way to minimize all this. But this one we use Markforce, so this is the best Markforce can do. Okay, the result is the flat and the side are quite comparable, but when we do vertical, then the elongation is very low. So the result is very similar to polymer. When we pull them, the vertical, when the loading and the layer are perpendicular to each other, they will have layer detachment. Okay, so that happened. All the testing result, they are actually met the standards, the industrial standard. So the dashes line, the industrial standard. Okay, for the bending, this is the fracture surface. Okay, for the bending is one of the most interesting one because we have the flat side and vertical. We put it in 3-point bending. Okay, this similarly is show the aspirin and the asinter that is get much about 13% to 14% smaller. Okay, and the difference between the flash and the size is much more in the bending, mainly because of the loading will be the load will be the shear will be in the direction of the printing the layer. Okay, and what happened that we observed that haven't been reported before is if it on the side sample, then that little triangle that I was talking about, they actually one alternate layer was missing. They're actually being and also was being squashed and being slide up as well. So this thing is we are still trying to explain why it is, but we repeat the test several times and it still happens. Okay, so people who want to use mix have to think about what happened with all the different orientation on the loading. Okay. We comparing the mix with the MIM. You see that this is the surface finish. For the mix, we always see the track of the layer, okay, and the print head. This is the top side, so the print head moving along, and this is the layer side, okay, and the bottom they will have quite rough. It's quite rough as well because mainly is actually from the alumina separator. The ceramic separator cause the roughness at the bottom. So this thing is not didn't expect it at the beginning, but it happened. Okay, the MIM is much smoother on top and bottom because we place everything into we inject everything into the metal mold. Okay. We also did some of the testing for the fatigue properties because all the sintering, the fatigue properties is the most important. The little porosity will link up and shorten the fatigue life. Actually, they are quite comparable and they makes comparable to the MIM. So MIM should be able to use in all the MIM application. Okay. Okay. We also, to improve the fatigue resistance, we have the work that we do, what we call the shot pinning. Okay, we after sinter we short peening them, and we also have because 7 to 4 pH we can age the sample as well. We have the age and we short peening. What we found out is actually the short peening itself, the one with the P at the bottom, okay, they actually smoothing the surface. The short pinning not only first thing they do is they smoothing the layer from the pinting or the head track, so they they become smoother and better surface finish. And the other thing that they do is actually they not actually affect the tensile property that much. But what is interesting is this: when we do short pinning and we actually introduce compressive residual stress onto the surface. So the compressive, you can see that the hardness at the surface, this is the surface, and this deep down into the material. The hardness increased significantly. So for the asinter and the asinter that we short pin, this is the S, this is the H1 and the H1 that we short pin. The compressive, the hardness increase 40% and 13%. When the hardness increase and the surface finish getting better, the pores at the surface get close up. What happened is they improve the fatigue significantly. These two, the bottom two are the asynther one and H1. But when we short pin, the fatigue property shift up a lot, improve the fatigue property significantly. So what we think is all the like the next sample we have to go to the pinning process as well to be able to make them have longer fatigue life, for example, especially for medical application. So depending on the application, if we focus on like surface finish, we have to use different processing. We focus on the fatigue, then we should use the pinning. Okay, yep. Thank you very much. Hi, I'm finished.
Yeah. Yes, I know you're finished. Thank you, Dr. Anjali. Now I would like to invite you to join our live Q&A. So just a moment. Let me open the permission on your side. So Dr. Anjali, are you um, are you able to join the live Q&A? Let's wait for a few seconds. Okay, before Dr. Anjali join, let me show you all the questions that I have received. And yes, on this platform, we will just post the questions one by one in the center stage so everyone can understand. Let's see. That will be our first question. I think this one. Oh, hello, Dr. Anjali. Can you hear
Hi,
me?
hi. Yes.
Oh, yes. Thank you for the very insightful presentation. Yeah, before you've been setting up the microphone and camera, let's go to this one question, shall we?
Okay. Yep. Okay. So the question is what can make use for any metals? So the answer is no. Okay. Unfortunately, not. Okay. Because they use sintering process, so the metals that we can use will be sinterable metals. Okay. For example, stainless steel, tool steel, and titanium. Okay. Things that we can't do is aluminum alloys and magnesium alloys because they have the oxide surface on readily on the powder that will prevent sintering. Okay.
All right, that's a very good one and very. I hope that answered your question. Let's jump to the next one. And before we move to the next one, delegates, let me remind all of you: you can still keep asking more questions. I'll keep an eye on the chat box. So if you ask question, I'll move that to the chat box for speakers later. Okay. So Dr. Anjali, let's deal with this question.
Okay, so the next question is what is the difference between MIM and mix binder? So the answer is they're totally different. At the beginning, when we start doing mix, we thought that we can use MIM formula for it, but eventually we found out that it's too brittle. Okay, if we use MIM, because MIM they extrude and then they eject directly into the metal mold, it doesn't have to be flexible. But when it's filament, you can just see that when it's filament, we have to at least spool them and feed them into the nozzle. So the formula is totally different. Okay, so those who got the MIM feedstock shouldn't put it into mix machine. Okay.
Okay, so that's that answer your question, I hope. So, Dr. Anchali, we have a new question coming, and the
Yep.
chat box actually in the right side in the chat box you can see it, right? So
Yep.
you can take a look at whether to answer it this questions first, or we can jump to the old questions first. Okay, you can tell me. You can give me orders if the next question, which one you would like to answer. Actually, because a while ago you've been setting up the microphone, so I pick up the question
Okay.
for you. But you can
Um.
actually tell me which one you would like to go.
Okay, yeah, yeah. The question that type in is like the question said that we have tried metal 3D printing
Sorry,
with
which one? The last one,
the
the
last one, yeah,
latest one.
the
Okay,
last
I'll just
one, yeah,
publish in the chat
yeah.
box. Okay,
Okay,
good.
yeah, yeah. With the conformal cooling and one or two piece is leaking. Okay. Um, the first question I have to ask back is which technique you use to produce metal 3D printing? Are you using MEX or SLM or other technique? There are different technique, but mainly because of the printing, the poor printing conditions. So you say that it's one of two that leaking. So it's the consistency in producing parts. So you should claim the manufacturer, yeah, to redo that one. Okay. So I mean, people still learning about metal 3D printing. So that could be the reason that why some of them are still not so consistent. Yeah.
I see. Okay, so I would publish the next question. I hope that answered your question. And also, as I type in the chat box, delegates, you can also keep giving us your feedbacks or comments to the answers we've been discussed. Okay, so let's go to the next one. How about this one?
Okay. So the next one is do we need both solvent and thermal debinding? So mean the mix technique. So the question is not really. It depends on the binder formula. Okay. So if you go for like the Markforged one, the Markforged and the Markforged metal mix machine or the desktop metal studio system, those things they design metal desktop metal studio system version 1 they design for solvent debinding and then thermal debinding and sintering, but like desktop metal version 2 that came out at the beginning of this year, they actually require only solvent thermal debinding. They don't need solvent debinding. So it depends on the formula. Okay, so in our lab we develop both formula. On the Asian side, like the Japanese and our lab, we tend to use the thermal only formula.
Okay, let's
Yeah.
go to the next one. Okay, before the we do the next one, due to the time limitation, we might do one or two more questions only. Okay, so Dr. Anjali, would you like to go to answering
Okay,
this question?
so this is the most common question I always have when I talk about titanium foam. People ask what is the application, the titanium foam I show in the slide. And the company, the the customer of that company, Taisei Cochlear, that they ask us to develop the process. They use it for the purpose of high specific surface area, okay, in as a cathode and anode in alkaline water machine. Yep. So mainly just have high porosity that water can flow to it. Yeah. And high
Right.
corrosion resistant. That is why they have to be titanium. Okay.
Okay. So I guess this will be our final question for today's session. But delegates, you can still chat in, give your questions in the chat box, or you can email us your questions to the speaker. Dr. Anjali, if you like, you can also share your contact information with me, so
Yep.
delegates can email you for more questions or for the further discussions as well. So okay, let's do the last one.
Okay. So The last question is, has MEX being used in real application? So the answer is yes. Yeah, okay. If you go to the website of Desktop Metal and Markforged, you will see that they show a lot of application in that their customer have been used. The only issue with Markforged and Desktop Metal is they are very expensive. They are closed system that is supposed to be like you put the 3D model in, you get the metal part out, but it's not really that easy. Okay, but they're trying to do it to be really user friendly. Okay.
I see. Okay.
Yep.
Since that's our last question, before we say goodbye to our delegates, Dr. Anjali, I would like to ask you to give us some conclusions or some highlights you like delegates to remember.
Okay, so the takeaway points is that apart from the laser 3D printing, you also have other 3D printing for metal as well. So you can have the sinter-based one. Okay. Yep.
All right. So that will be our conclusion for today's sessions for Dr. Anjali. So Dr. Anjali, thank you very much for joining our conference today. You may stay for listening to our other speakers too, or you can just simply say goodbye to our delegates today. I'm looking forward to invite you to join our platforms and webinars in the futures as well. See
Yep.
you.
Thank you very much. Bye.
Okay, bye-bye. Okay, delegates. Now, let's go back to our agenda. For our next speaker is Dr. Rentor. But before we introduce you to Dr. Rentor, I would like to tell everyone that we are gonna have a short tea break right now. Even we don't share, we don't give you some tea to drink. But we were gonna have a 10-minute tea break, so you can go to toilet or you can have a break for drinking coffee and water. But the very most important thing is that I would like to invite you using this time to visit our sponsors booth at the eBooth page. Okay, at your left hand side, please go to eBooth, visit their booth and watch the videos, maybe ask some questions to their informative technology or products as well. So I will play a short video for 10 minutes. After finish playing the video, we will go back to the presentation and we were gonna have a very interesting, I have to say, very interesting topic for brought by the speaker, Dr. Rentor. So delegates, stay tuned. I'll see you guys later in 10 minutes.
Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything, from simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over.
Okay, who else need more time to visit the booth or to do other things? Please in the chat box tell me if you need more time. Otherwise, we're gonna start our next presentation for today's sessions. Okay, so delegates, if you can hear my voice loud and clear, once again, in the chat box, please say hi or say yes to me so I can know we can actually proceed. Okay, delegates, I'm looking forward to hearing your voice, and saying hi to me will make me very happy today. So I hope you can do that to me. Thank you very much. All right, let's give a few seconds for everyone, waiting for them to get back to their seats. Okay, we're about to begin. So delegates, please. Okay, good. Okay. Oh, good. Wonderful. Okay, thank you very much. Now let's proceed. Okay, before the tea break time, as I promised, I will introduce the very great speaker for today. He has a very interesting topic. Our final speaker, Dr. Rantor Y. Cafino, brings a wealth of experience as a medical officer and unit head of ENT HNS Medical Makerspace at Zamboanga City Medical Center. Prepared to be inspired by his presentation on hospital-based 3D printing, as he shares the invaluable experience of Zamboanga City Medical Center in this groundbreaking journey. And also, during his presentation, please get prepared with your questions and your comments as well. You can share with us your ideas as well. I have to remind all of you, he's gonna share a lot of samples and videos and even some very good experience on this field. I believe it's very interesting to you. Uh, so delegates, prepare for his wonderful presentation. I'll see you guys later.
A pleasant afternoon to everyone. I am Dr. Rentor Cafino from Zamboanga City Medical Center, and I was invited to give a talk on the innovation and the use of 3D printing in the medical field. And my presentation this afternoon is entitled Hospital-Based 3D Printing, Our Experience, or the Zamboanga City Medical Center Experience. We're a relatively small hospital located at the southern part of Mindanao, which is a place in the Philippines. We are an 800-bed capacity tertiary government hospital, and we serve as a catch basin for the 98 barangays or small towns populated by almost, if not more than, 1 million people in the surrounding area. We are a training hospital, and this is just one of our buildings. We are accredited with several surgical specialties, such as our general surgery, my department, which is the ENT/HNS, and OB/GYN, and as well as many other accredited departments. We receive a lot of surgical cases, most which are complicated and entail specialized management. So the ENT/HNS medical makerspace started way back 2019. It was started by me and my fellow co-resident, which was the time when we were still training. And then all of a sudden, we were hit out of nowhere by the COVID-19 pandemic in late 2019 and, of course, 2020. This forced us to collaborate with many other institutions to help supply the need for personal protective devices during this time. So one of the institutions we have worked very closely with was with Mindanao State University Institute of Technology. And of course, that's where we got introduced to the Fab Lab or Fabrication Laboratory in Mindanao. During this time, the supply chain was crazy. It was difficult to get supply of just even the basic PPEs. And of course, I think some of you are familiar with how additive manufacturing was used to supplement this lack of protective devices. And here you can see several of our doctors and nurses enjoying more than 400 face shields that we have distributed among healthcare workers in and outside of our area. And then as the pandemic progressed, we realized that we could do more than just face shields. And so brilliant minds from across the area and of course within our hospital started thinking about how more we could help with this pandemic. So one of our colleagues invented a droplet protection device that could be attached to an endoscope camera, as during this time it was difficult for us to see patients due to the, of course, scare of getting COVID-19. We were able to use this to examine our patients, and you can see here one of my colleagues still in full personal protective device examining patients during the height of the COVID pandemic. We have also made portable endoscopic devices that help us examine patients even during the height of the COVID-19 pandemic. Here is one of our nurses acting out how we did our examination during this time. So unfortunately, we realized that this fluid shield was not enough we needed to do more complex and more invasive and aerosol generating procedures. And during this time, it was very difficult to secure things needed to make, of course, things such as the what do you call this, examination box. But however, with the use of 3D printing, we were able to make fixtures and design fixtures and print it out ourselves. And because of that, we were able to make a modified negative pressure booth. This helped us do even more invasive procedures and aerosol generating procedures. And we did our swabs, which allowed us to perform all of these procedures using very minimal personal protective devices. As you noticed earlier, my colleague was in full PPE, and here we are only using gloves and mask. This helped us during this time immensely because there was a lack of PPE, and having to just use gloves and mask was a great help and did not strain the supply of PPE that much. And up to this day, we still use this booth for patients who are COVID positive or suspected of having COVID. During this time, our colleagues at the anesthesia department were having trouble doing intubations because it was a difficult time for everyone working within the airway. So, inspired by several online designs of video laryngoscopes, we designed and 3D printed our own video laryngoscope. Here you can see a video laryngoscope that we designed, which utilized some cheap off-the-shelf USB cameras attached to a cellular phone. So these were lightweight and could be disposed after a single use. Here you can see a demonstration by one of our anesthesiologists using the video laryngoscope that we provided for them. Another thing that we utilized our additive manufacturing for was to create a system wherein we could examine our patients. So during the COVID-19 pandemic, as I'm sure most of you know, it was close to impossible to examine patients face to face. However, in our department, we designed the system following the rules of the DOH, where we had to have 1 meter distance and be in PPE. But our system allowed us to be in the most basic PPE, which was just a face mask. So you can see here, me and my colleague demonstrating how to use the so-called on-site virtual examination system that we created. So this was just a simple table that separated the patient and the physician. We had USB cameras that were designed to be used by the patient for a quote-unquote self-examination. So the physician sits opposite the patient. We are separated by a clear plastic barrier. The fittings and the devices were made using 3D printing. And here you can see the patient doing an oral cavity examination using the so-called device. This device was just a USB camera, again, an off-the-shelf USB camera that was fitted with several attachments, making it easier for the patient to use. And because it was on site, the patient could be instructed by the physician on how to use it. And of course, the human factor is still there. The patient is able to communicate with the physician without the physician being in full PPE. So the patient can still see the face of the physician. And it greatly helped with us examining our patients this way, as we did not stop our operations during the COVID-19 pandemic. Here are a few pictures that we took during this time, some infections, a fungal infection right here, and even some foreign bodies that we got to see during this time. And of course, here are some other pictures. We were able to do all this through the help of the system that we created called our on-site virtual examination. Eventually, this so-called system was evolved into off-site virtual examination, where we used the same system with a modified attachment to the camera that allowed the patient to use it without having to think about which way is up and which way is down. This could be used with a tongue depressor to help in the examination of the oral cavity. So from 3 USB cameras, we now reduced it to one camera that could be used to examine all three orifices, so the ears, nose, and the throat. We even made an online consultation kit, and here is one of my colleagues examining a patient through an online consultation. And after this, we got to train several physicians from the neighboring provinces to use this so-called system for their patients. As the COVID pandemic ebbed, we got to link with over 30 fab labs and maker spaces all over the country, and of course outside of the country. And we are still linked with them to up to this time. So the makerspace was created with the vision of assisting doctors, medical staff of our medical center in integrating new and emerging technology, more specifically additive manufacturing, into the medical field by fostering research and innovation. We aim to be a fully equipped medical makerspace. So we started with like one or two small 3D printers, and we're now up to quite a lot. We want to be able to provide the means necessary to turn the innovative ideas of our staff and their methods into reality. This is our team. We are headed, of course, by our very, very energetic medical center chief, Dr. Afdal Bikunting. Of course, under the chairman of our department, Dr. Paber. And here you can see me overseeing the entire makerspace. And we are now quite a lot from just two people. We use our 3D printing mostly for medical purposes, for education, surgical simulation, surgical planning, and of course training. So allow me to share a few of what we have been doing, a few things of what we have been doing using 3D printing in our medical field. In the most basic sense, we use 3D printing to create patient-specific 3D models. So these models are extracted from the patient's imaging. More often than not, we use computed tomography or CT scans. This allows us to improve our communication to our patients prior to them undergoing surgery. So this is me explaining to a patient how much of his face I would have to remove. Normally, this is a very difficult procedure to convince patients to undergo. But once they see that their skull or the part of their face actually has like a big tumor that has to be removed, they seem to be more receptive to undergoing the surgery. And it also helps us communicate our plans more effectively to them. We also use this to train our residents. So this is my chairman and one of our consultants discussing a surgical plan using a 3D printed model. So we use this to make training more tactile and visual for our residents. We also use our case-specific 3D printed models for surgical simulation. So we 3D print a model and then we have our residents practice surgical techniques on the models. During this time, we had residents who were afraid to use a hammer and chisel on a patient. So we had our resident practice on 3D printed models first before proceeding to the actual surgery itself. This is one paper that we have worked on. I'm sure some of you have already seen 3D printed models, and one of those that have been really impactful in our practice is a model of a temporal bone or the bone of the ear. So here you can see a 3D printed model. This is printed using resin. We created this model, extracted it from a patient's 3D CT scan, and practiced our surgery on this. In reality, the dissection courses for temporal bones or ear surgery exists. However, it is very limited and costs quite a lot. If the 4-year training of a surgical resident, we get to do this course once due to, of course, the limited amount of slots available and, of course, the cost. With this 3D printed model, it allows us to perform relatively unlimited amount of practice surgeries on not just generic cases, but of course specific cases, each tailored to the kind of case seen in our patients. So here is the 3D printed model and the model under a microscope after drilling out the area that we needed to access. We have tried to find out which material and method was the best for this, and we discovered that 3D printing this temporal bone in resin seemed to work out best for us. And up to this day, we still use this method to train our residents in surgery for the ear. So I would want to apologize in advance for those who are quite squeamish, but I would be presenting quite a few cases, and they're a bit uh, hard for the untrained to see. So for those who are squeamish, please turn your eyes aside. For those who are interested, so please keep watching. Here we have a 46-year-old male we saw previously, and he had quite a large tumor on his jaw. So what we did was we 3D printed the patient's jaw after doing surgical planning on the patient. We then pre-bent or pre-contoured our implant, which normally takes quite a long time. So it takes about 30 minutes to an hour, depending on the surgeon's experience. And we did this prior to doing the surgery. After removing the tumor, we were able to place the implant without having to do any more adjustments. And this is the patient after the surgery. We were able to preserve the contour of the patient's face. Of course, there's still a bit of swelling going on here, but eventually the swelling died down. The patient is still scheduled for a definitive surgery with microvascular implants, but for now, the patient is pretty happy with how it looks like after the removal of the tumor and the replacement of the missing bone using just a titanium implant. This is another case. We saw a 39-year-old female with an 8-year history of large, slow-growing mass. So we did the same thing. We did our surgical planning and we pre-bent our implants, but this time we used a rib graft to help augment the lack of bone. And this is the patient after the surgery. And a funny story for this patient is the patient did not follow up for quite some time. She apparently did not have enough funds to come back for consultation as she lives in a far-flung place. The reason behind this was she had her hair done because she was very happy with how she looked like. And we were very happy to see her also. So there's still quite a bit of loose skin, which would eventually contract and leave her with a better looking appearance than this. Another case, but this one is a case referred to us by our colleagues at the general surgery department. They did the case, we only helped them with the planning. So what we did was we prevent again the plates using virtual surgery and a 3D printed customized template. We then help them during the surgery to implant the pre-bent, pre-contoured implant, and um, this is the patient after the surgery. Another case here referred by our colleagues at the thoraco-vascular department of surgery. This is a 7-year-old female who had quite a lot of fractured ribs. So to help reduce and secure these ribs in place, they referred to us for 3D planning. So what we did was we mirrored the normal side and tried to get it as aligned as possible. This allowed us to pre-contour our implants. So without much fuss, we were able to place the implants with very little, if none at all, the need for adjusting or in surgery adjustment. So here you can see the X-ray of the patient with relatively good placement of the implants. So right now, the lab is working on 3D printed implants. We are focused on utilizing engineering grade polymers for craniomaxillofacial implants. So this is what you see, an actual implant that we are testing right now. We are trying to deviate from the normally more rigid titanium implants, and we're trying to explore engineering grade polymers for our implants. So this means that we are able to 3D print these implants at a lower cost than 3D printing metal, which is titanium, and hopefully be able to achieve the same amount of rigidity to maintain fractures and hopefully bigger defects. So initially, it was very difficult for the lab have um, to have projects to work on, as we were not that exposed. But during this time, we tried to promote it as much as possible. So we during the National Hospital Week, we set up a booth and we promoted what 3D printing could do for medicine. And fortunately, a lot of people came to visit and they got to see what medical 3D printing was all about. And this allowed us to host trainings for medical 3D printing. So here is a training for Fab Health. This was in partnership with the Fab Lab Mindanao from MSU IIT. And here is more of our pictures during training, teaching them how to extract the anatomical parts that they needed from patient CT scan. And even more trainings this time with our local institution. We have our medical school. We have, I think, here with us is the engineering schools also, who are also interested in 3D printing. Recently, we held another 3D printing immersion with the biomedical engineering students who are also interested in utilizing 3D printing for their innovative ideas. One group recently reached out to us. This is a batch of nursing students from our local institution, Ateneo de Zamboanga University, where they wanted to create a device that would protect nurses from needle stick injuries. So as you can see here, they designed a device that could protect their fingers from needle stick injuries when uncapping and recapping syringes. So it worked out pretty well, and I think they got a really good grade during their thesis defense. Here are more pictures of us doing our training, our 3D printing training, and here are the biomedical residents from Ateneo de Zamboanga University with their goofy poses and goofy prints. So we have fun also. So that is all for the medical maker space. I hope that it shed some light on what we do and how 3D printing could be used in the medical field. So as we say in Zamboanga City, muchísimas gracias.
Very interesting presentation, right? As I said. Yeah. So Dr. Rentor, please, we have a lot of questions in the chat box actually. So we're looking forward to joining you, for you to join in our live Q&A session. So, all right, delegates, I will also send the contact information of the Dr. Rentor's contact information in the chat box. Yes, I see. Okay. Sorry, delegates. Dear delegates, once again, bad news for today's. Dr. Rentor Cafino has another urgent schedule, so he cannot join the presentation Q&A, live Q&A after his presentation. However, yes, he said if you email him all the questions you like to ask after listening to his presentation today, yeah, he would love to have discussions with you, and also yeah, he love to reply to your questions and emails as well. So that's why that's very important. We have the feedback form for all of you. See on the screen, please use your cell phone to scan the QR code right now. In the chat box, you can leave us every comment you like to share with us to this event, to Ringer, to me, Jack, or to other speakers today. You can ask questions to us, ask questions to the speakers. You can leave your comments to us and your suggestions maybe as well, right? You can tell us how to make a webinar or a conference which is better for you. You can suggest a topic to us. You can tell us uh, your wishes about our events in the future. So we would like to give you better service. Okay, so I'll leave the QR code on the screen. Now, since we have all the speakers have very interesting presentations show us today, here as we draw to a close, we would like to thank all our speakers who shared their expertise in today's summit, and also especially HBD for being our business partner today. We look forward to collaborating with you again shortly, delegates. Most of all, Ringer Events would like to thank all our participants, and we would like to appreciate your feedback as well. So don't forget, leave us your comments, and yeah, if you'd like to say anything to me, Jack, please say something nice for me. Yeah. On behalf of Ringer Events, we would like to thank all of you and hope that this webinar, this virtual conference can help you establish new business contacts as well. So happy holidays, and we look forward to seeing you once again in our next webinar, next online event. Until next time, take care, everyone. Goodbye.
Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over the long term. Our technological accumulations are in continuous innovation and development. Our rooted industry is backed by more than 100 patents. We are the market leader with a global footprint. Our ability to shape quality is through talent and excellent teams. We care most are the technology and service quality. We are HBD. Make the future happen. Those saying impossible are just saying no to greatness. HBD, as an additive manufacturing machine developer and solution provider, is continually digging into techniques, breaking boundaries, and exploring new areas. We create solutions with wisdom. We innovate beyond goals. We guarantee high efficiency. From nothing to everything. From simple to complex. Each detail matters. We strictly control the supply chain management. We follow the detection process at every stage and each step. We ensure optimizing machine performance. With our application processing and inspection centers, we offer customers with in-depth cooperation and customization. During the digitization process, we open the Smart Manufacturing chapter. In an automated production line, we infuse the machines with our thoughts. Ensure all production details are managed in compliance with standard systems. Working with the leading global suppliers, we guarantee high quality, high precision parts. We achieve high quality by 190 plus process tests and 30 plus pre-delivery inspections. Each idea is meticulously planned. Each part is carefully prepared. By combining technology and intelligence, forging the future-proof factory. With cutting-edge application technologies, our products are serving aerospace, energy, molds, automotive, medical, education, and scientific research, aiming to create maximum value for users and partners. We developed a control system to provide micron-level calibration accuracy in order to ensure high-precision printing over